So, all we're going to work on today is how to multiply, add, and subtract matrices. It's pretty simple. I'm going to show you how to do everything by hand too, because it's actually quicker by hand sometimes. But you have the option of doing it all on the calculator as well. Okay? So first, let's start with some simple addition and subtraction. Okay? For adding, let's highlight this. The dimensions must be the same. Okay, same thing with subtraction. So for example, if you look at the problem down here, which of these three could we add or subtract together? Yeah, these are the only two, right? You can do A minus B, A plus B, any combination. This C you can't really do anything with as far as adding or subtracting, okay? So real simple, to add A and B together, if this is a, what is this? 2 rows by how many columns? 2 by 4? 2 by 4. Okay. This is a 2 by 3, yep. When you add, the dimensions will be exactly the same as the two things you're adding, okay? And it's pretty simple. All you're going to do is add every number that corresponds to the same spot. So for example, in this first row, first column, you would just do 2 added with -3. So what is that? -1. Then you just go entry by entry. 4 and 4 add up to 8. 8 and 0, also 8. -3 and 1, -2. And then you do the same thing with the bottom row. 0 and 6 is 6. 1 and 8 is 9. 2 and 2 is 4. 3 and 0 is 3. Okay? Are there any questions on how to add matrices? Pretty simple, right? Subtracting is going to work the same way, but instead of adding, you would just do 2 minus -3. So what would that be? 5. What's the rest of it? 0. Okay, and the bottom row?
-6.
0 minus 6 is -6, yep. -7.
0.
And 3. You guys see where we're getting all those? Okay. Now, let's just talk about this one real quick. You'll notice that in front of the A and in front of the B, there's a number. We call that a scalar. Okay. But if I asked you, what is double A going to be? Looking at A, what would you do? Just multiply everything by 2. That's what that means. Okay? So it would look like this. 4, 8, 16, -6, 0, 2, 4, 6, plus, and now we're going to triple B, so that's -9, 12, 0, and 3, 18, 24, 6, and 0. You guys see where we're getting those two? Okay, and now you can add them. Remember, it's kind of like order of operations. You got to multiply these little numbers through first, and then you can add everything up. Okay, so your final answer. Yep.
16.
Good. Uh-huh.
26.
Good. Pretty straightforward, right? Okay. We're going to skip that one because if you can do this, you can certainly multiply a matrix by -3. Can we do B plus C?
No.
So we would say not possible. Dimensions must be the same.
What does it mean by dimension?
Yes, yeah. It's got to be exactly the same size. All right, so that's adding and subtracting and multiplying a little number through to the matrix. The last part I wanted to show you by hand is multiplying a matrix with a matrix. It's a little different than multiplying like a 2 with the matrix or a 5 with the matrix. Okay? So here's how it would work. So first, matrix A, what's the size here?
2 by 3.
2 by 3. And what's this one?
3 by 2. 3 by
Careful. 3 rows, 2 columns, right? Okay. So we're taking this matrix here times this matrix here. First things first, in order to actually multiply these matrices, it's not the same rules as addition or subtraction. You can multiply matrices with different dimensions as long as this number of columns and this number of rows are identical. You can do it. Okay? So as long as these inner numbers are the same, you can do it. It could be a 2 by 5 and a 5 by 2. Doesn't matter. As long as these match, and you'll see how it works in a minute. And the cool thing about this is that the outer numbers, this 2 and this 2 on the outside, that tells you the size of your answer. So when you're done, that's going to be how big your matrix is, 2 by 2. Okay? And now I'll explain this, and then we'll actually do it. But when you multiply a matrix with a matrix, okay, here's a good way to remember how to do this. We agree it's going to be 2 by 2. That means there are 4 spots to fill, right? What row and what column is this? This is row 1, column 1. So remember that. Row 1, column 1. So that means you're going to take row 1 from the very first matrix with column 1 from the second matrix. And what you would do is you multiply first number with first number, second number with second number, third number with third number, and then you're going to add all those numbers up to get one final entry. So if we do that, 0 and 4 is 0, 3 and 2 is 6, so just remember that. And then negative 4 and negative 3 multiplies to 12. So add everything up, we get 18. Okay, it's a little different than what we're used to, but that's how you would multiply. Okay, and then essentially, if you remember this, now you're going to take row 1 with column 2, and that'll tell you row 1, column 2's entry. Okay, so what would that look like? 0 and 18 and negative 8. 18 and negative 8 is 10. Does that make sense? Once you're done with the first row, you're done using the first row from that matrix. Now you repeat the process, and now you do row 2 with column 1 and row 2 with column 2. Why don't you guys try those last 2 numbers on your own? All right, so what did you guys get for this first number? Everybody got 4?
Yeah.
Okay. And then for the second number? 23. Okay. Any questions on that? Okay, a couple of quick things, calculator issues, and then this is something that we just talk about. It's pretty easy to remember, but if you see I, okay, I refers to an identity matrix, and if you don't know what an identity matrix is, it's simply a square matrix. A square matrix means that it's same rows, same number of rows, same number of columns. So we're talking 2 by 2s, 3 by 3s, 4 by 4s. You'd never see I with like a 5 by 7. That's not possible. Okay? And all it means is that this diagonal is 1s and 0s is all the entries for everything else. Okay? So down here, 3I2 would be the same as 3 times what matrix? 1, 0, 0, 1. Does that make sense? A diagonal of 1s here and then 0s everywhere else. Okay? So this is really 3, 0, 0, 3. Okay? And just because we haven't talked about it yet, let's just talk about the calculator again in case you forgot. All right? You can do all the stuff that we talked about on the calculator. All right? So just to review, I mean, we already know what the answer is because we did it. 1810, 423, that's what I would be adding with this. But just to get comfortable with the calculator again, if you go to the matrix menu, since we're using A and C, I might as well use the same letter, so I'm going to go to Edit. And what was the size of A? 2 by 3. Now you just put in the numbers, 0, 3, -4, 1, 3, 2. Back to the main matrix menu. Now we're going to use matrix C, so Edit, matrix C. That one's also 2 by 3. Where is it? C was, oh no, C was not 2 by 3. Thank you, it's a 3 by 2. And now we put in those numbers, 4, 1, 2, 6, -3, 2. All right. Since we're adding that product with this matrix, I'm going to create a new one. Let's just call this B, since we're not using B anywhere. So matrix, go to Edit, matrix B. That's a 2 by 2. And that's 3, 0, 3, whoop, 0, 3. There we go. Once you have everything stored in there, you can now do matrix A times matrix C. And that confirms what we did earlier, right? 8, 10, 4, 23. We already got that part. But now we're adding this other matrix that we put into B. Okay? Make sense? Any questions? Again, if you're good at the mental math, do you see how doing these by hand sometimes is quicker? I mean, doing this on the calculator, you got to like press all the buttons, and I mean, you can do it either way. Either way you do it on Thursday, it'll be fine. Okay?